Hi everyone, my topic is intention detection and thought feeding with field training data. My name is Yuhao Lin and my supervisor is Lingqiao Liu. What is intention detection and thought feeding? Most of you may not heard of it before. The task is about natural language understanding, which is a difficult part in NLP problem. Here is an example of what I'm doing now. The A said, "Hi, I'm looking for a nice German restaurant." And the B said, "There are no German restaurants list. Do you have another preference?" Here just a one-term dialogue, but for real situation, I will have a multi-term dialogue. What I'm doing is I need to predict the intention or the value of each slot. The value and the slot are given. So for this turn dialogue, the status is error is none. It means it's not mentioned in this dialogue. And food is European, and the price is also none. In recent years, deep learning and related technology are used in NLP tasks, and the result improves greatly. However, in intention detection and thought feeding, the most advanced models do not have the generalization abilities, which means they are just suitable for one or few particular domains. For example, in restaurant domains in last slide, we have 3 slots, and for each slot, we have 6, 94, 8 values. But in another domain, like hotel booking or taxi booking, we will have 4 slots or more, and for each slot, we will have different number of values. So the models trained on the restaurant domain cannot be used directly in another domain. Another problem is current method cannot recognize some specific object name. Also in the restaurant domain, if we just ask for some specific dish name, the model cannot recognize it. Therefore, our goal is to build a universal model that can suit many domains. And we hope it have the ability to recognize some specific object name, and we also hope it works well. There are 2 kinds of datasets in this task. One is multi-term dialogue, like this I showed here, and another is for one sentence prediction. I use the multi-term dialogue as I think the one sentence prediction is not as meaningful as this. And I want the model to track the states in last term. So the verse is for restaurant and the multiverse is for multi-domains. It has 7 different domains and about 22 thought values. They are all in form of dialogue. Here we can see there are 5 terms dialogue, and for each terms it has the corresponding status. In my work, the most important part is BERT, which is bidirectional encoder representation from transformers. In BERT, they use a brand new block called transformers instead of using the traditional methods like RNN and CNN. The whole implementation of transformer is based on attention mechanism. More precisely, the transformer is built with self-attention and feed-forward neural network. A trainable neural network based on transformer can be built by stacking transformers. In this paper, BERT, the author built an encoder and a decoder with 6 layers each, a total of 12 layers of encoder-decoder structure. In traditional method like RNN or LSTM, they cannot handle with a particular long-term dependency. In self-attention mechanism, it reduces the distance between any 2 elements in the sequence to a constant unit, which is very effective for solving the difficult long-term dependency in NLP problem. Secondly, it is not a sequential structure like RNN, so it has better parallelism. It accelerates the computation of GPUs. And BERT is based on the transformers and trained with billion sentence in Wikipedia. So we use this for embedding and fine-tune it. Here we can say, here is the usage of BERT. Every sentence using BERT must be in the form of CLS at test A. If has test B, we will add as SEP in the middle, and then add test B. And we will add a SEP in the end also. In the paper, it says The CLS token can be represent the meaning of the whole sentence. And one thing very interesting is that the same word with different contexts can be translated differently. It is very reasonable. And a paper called A Simple but Effective BERT Model for Dialogue State Tracking. In this paper, it added a linear layer after the CLS token, and it calculates the relevance score with it. And our method is based on this paper. Another great method is called Belief Tracker. It is a new method as it is proposed in 2016. It will encode the dialogue slots and the values separately and then compare the similarity between the context modeling and the semantic decoding. At the very beginning, our idea is to fine-tune the BERT and add a linear layer after the SCP tokens and add some semi-supervised element in it. For instance, the AMR here, the abstract meaning representation, it is a graph neural network method. There are two spatial tokens in BERT. One is CLS and another one is SCP. CLS in the front slides, it said it can represent the whole sentence. So we believe that the SCP tokens can also represent some hidden meanings. For this reason, we will pre-process our data like this form: CLS at test A SCP, test B SCP, and add the slot and the slot values, all the slot values behind, and separate them with SCPs. So for one sentence, we will have the number of slots corresponding sentence. And then we use a linear classifier to train all the SCP informations from the fine-tuned BERT. Here is a figure of our network. Here we can say the front part are almost the same from the paper. The dialogue context is the same, and the only difference is the behind part. We will add all the slot and the slot values behind, and we get all the SCPs here and go through a linear layer, and we got the relevance probability distribution. So for n slots, we will have n network like this, but the result is not good. After discussion with my supervisor, the reason of the failure may be the different sizes of the slot values. Then we tried a belief tracker with BERT embedding. This method is based on a paper called SUBMT. We will encode the uterus domains with slots and each values of the domains respectively. We will encode these three parts with two BERT. We use one BERT for uterus encoding and another BERT for domain slot and values encoding. Here is a figure of our second method. And we can say the uterus after first BERT encoding will get all the uterus hidden information here, the use. Then we will pass the use to attention to get the hidden feature of that term, and then pass it into RNN or LSTM, then normalize it to get the final result. We will compare the final result with all the encoded values to get the most similar one as the prediction. The result of our second method is not bad. It has 89% accuracy and can handle with new word. Let's say it together. Here we will try two names of dishes. One is bacon egg. It is famous British food, and another is Gongbao Jiding. It is a famous Chinese food. So here for easy understanding, I will use just the one-turn dialogue. The maximum of dialogues is 8. So here I just say, hi, I want to have what. And the result is area is known, food is British, price is known. It can recognize the bacon egg. And I will try Gongbao Jiding. It is a little bit challenged. Yeah, the results is quite good. For the Chinese and it shows that it can recognize the Gongbao Jiding, and this never appear in the training data. So we go back to the slide. For the few data part, we trained it with 1, 2, 3, 4, 5, 600 data separately, and the result shows that 300 and 400 data can have the same performance as the 600. So we conclude that using pre-trained models can reduce the number of the training data. About the future work, if I had another 6 months, I will investigate some other methods for all domains, and I want to improve the performance, and I will add some AMR into the models. Yeah, so thank you for listening.